Yeah, so we shared the roadmap, and hopefully everyone has seen that. I want to explain, why this flow, why this approach to the different parts, and also in particular because I know different people have different areas of interest when it comes to this. Some people are more interested in just the spiritual side, the let's say the connection with God, that part of it, which will be actually part 4. Some people are more interested in the deep philosophical questions and debating different ideas there, arguments and counter arguments. And we get to that part in part 3. But actually, I start with a focus on science, the natural sciences, and mainly physics, biology. And there's a reason for that. And that's what part 1 and part 2 are about. And there's a real reason for that. And that is because that science in today's world, we find that we live in a scientific age of technology and deep scientific advancement, and a lot of people are kind of moving away from anything religious in a belief in God, and more you see people going towards saying basically something like, I believe in science, I follow science, I believe in the science and being scientific, I don't find that religion is scientific, I believe in science. And that's why I wanted to start there, actually, because I want to make sure, first of all, that we understand what science is actually telling us, number one. But the second is that we need to understand how what science can do, and what we can learn from science, but also where science stops when it comes to these questions and is unable to go further. It's not made for that. It's not its role. Beyond science comes philosophy, and it's unavoidable because science basically tells us what is the behavior of nature. Okay, how does nature behave? That's what science tells us. It does not tell us what nature is in that of itself. What is it made of? What is it? Why is it here? Why is it not some other way? Those are questions that are philosophical questions that cannot be answered by science. So you can have deep respect and be grounded in science, but you can't believe in science. You have to actually go to philosophy and form a belief about philosophy. It's not possible to actually stop a science. A lot of people don't understand the difference between these two. So I spent quite a bit of time trying to make sure that that's very clear. That's one thing. The second thing is that I believe that any good understanding of reality should be informed by science, okay? Meaning that whatever I end up believing the nature of this reality is, what is this life about, what happens after we die, all of these big questions, I'm not going to be very happy with a view that would maybe contradict what scientific evidence is telling us, right? If you're telling me something you believe, and then I can actually see directly from scientific evidence that it doesn't make sense and it's contradicting it, I think most people, everyone please make sure you stay on mute. Everybody should be on mute unless they're going to speak. So I was saying that everyone please stay on mute. Thank you. I was saying that, yeah, if you have a clash, right, then you're going to be in trouble, especially in an age like today. We live in an age of knowledge and science. It's very difficult for someone to just say, oh, I'm going to ignore that and I'm just going to believe something else, right? So science can inform our metaphysics, our philosophy, our understanding of reality. It doesn't mean that it decides it, but it shouldn't clash with it. Okay, so that's the main reason why I start with science, because science just tells us, okay, we live in a world and we need to understand what is the behavior of this world. What can we learn from studying the physical world around us? And this should be the starting point. And because that's something we can all agree on. We can do experiments, we can test things repeatedly. Anybody can come and repeat the experiment and they see the same result. So we can all agree this is the way nature behaves. So it's an important starting point before we start speculating about what does it all mean and what is it all, how do I understand all of this? Let's agree on the facts, and that's what science can inform us with. So that's why in this roadmap we start by examining and understanding what is the scientific evidence, what are the insights we can take from science. After that, we go to part 3, and that's really philosophy, the mental world, trying to understand and interpret what we have learned from our scientific investigation and form some views that can make sense of it and be a good grounding for our outlook and our viewpoint on life. And then the last part is really, once we've done that, there is an experiential dimension that we will explore, because there are different ways to know, right? Knowledge can be gained in different ways. The first part is through just actual experience of the outside world, right? The external world. That's the first step, which is part 1 and part 2. In part 3, we can understand things intellectually, using rational thought, using logic, using ways of trying to make sense of concepts. That's a mental, intellectual way of knowing, right? That's what we explore in part 3. But as existing beings, we are conscious and we are having experiences. Every moment we are living in a world of experience. In fact, that's what we own. That's the only thing we actually have access to. We will always have only our own direct experience. And so when it comes to these questions and the existence of God and a relationship with God, how can I experience this rather than just understanding it with my mind or even just believing in it? It's about the experience. And that's what part 4 is about, the experiential knowledge that we can gain. So as you can see, there's a wide range of different disciplines that we are covering here. And altogether, my approach, you can summarize it as, they call it the mosaic approach to learning things. So everyone hopefully knows what a mosaic is. And essentially the mosaic idea says that we have different pieces of, like a puzzle that we're putting together, or mosaic, a picture. And so any single piece is not going to give us the full picture. But before we make a decision about what is this picture, let's actually put together all the different pieces like a mosaic and see what is the most convincing conclusion that we can reach from that. Okay, so it's a mosaic approach. So what we'll do when we say part 1 and 2, we'll go into science. Part 3 and 4, we go into philosophy and spirituality. We won't reach firm conclusions until the end. All the way along, we're kind of gathering or exploring one way of looking at things, and then we kind of take a time out, we park it, and we go to another approach, and we look at it from a different perspective. And then we stop there, and then we look at another one, and then we bring the whole thing together in a mosaic, okay? So sorry to take too much time describing it, but I think it's important to see how the flow of the discussion will be and why it's approached this way. There are other ways to do it, of course, but for me, this is my personal journey has been in this way. And I do think it makes sense to approach it in this sequence. Last thing I'll say before diving in is a general kind of methodology that I have is that I will start by laying out facts, things that are established, they're not controversial or something. If there is something that is not fully agreed on in a widespread basis, it's a minority view, I will make sure that I make that clear so that we're all aware of what the facts are, and then what are the views out there, and what are the opposing views. Okay, so one way of interpreting, another way of interpreting, and then I'll share my own perspective as well. And then hopefully we can have discussions around all of this. Nothing is off limits, and I hope that everyone will challenge everything that I say wherever it doesn't make sense, because I've tried my best through my entire life to remain unbiased and objective, searching for the truth and following it wherever it goes. And that's the approach I take here. And so if there's any weakness in the argument, I'm hoping that people will actually come and attack me with that, because it's very important for everything that we say to be robust and convincing. Otherwise, it's not going to really transform us in any way. Okay, and so hopefully with the end of all of that, the end product should be a very coherent view of reality, consistent with science, rigorous intellectually, and then confirmed with personal direct experience as well. And what I've found personally is that when that is done right, it results also in a kind of internal confirmation through a sense of peace and happiness. That is a way that I believe nature is telling you that you're on the right track. All right, so with that, let us begin. So I start with physics because physics is really the most fundamental science, okay? And this is where we will start to look at the empirical evidence. What can we learn about the world? So this slide, I won't spend time on too much. We'll go into this later in philosophy, but this is a key thing that I was saying. The essence of nature is not a scientific question, okay? Science only studies how nature behaves, not what it is in itself. So when we do science, we do experiments, and experiments only settle questions of behavior, not what is this thing in itself. Those questions of being are metaphysical questions, and they will need philosophy. And philosophy has its own rules. Just like we have rules when we do science, there are rules when you do good philosophy. So when you have a metaphysical, philosophical answer to something, it should follow these rules. It should be, I'm not going to spend time on these now. I'm going to focus on just one of them, which is where we're starting. It should be logically coherent. It should be internally consistent. It should be parsimonious, which means it should be as simple as possible while still explaining everything. And then it should be empirically adequate. This means that the evidence, whatever view we have philosophically, our belief system, should be adequately explaining what we see from the evidence from science, okay? Empirical adequacy. So that's the reason why I start with physics, because physics is about the most fundamental elements of the world around us. Everything boils down to, the physical systems we have. So biology, chemistry really boils down to physics. And then physics tells us what are the fundamental building blocks of the physical universe and how do those behave. Okay, so this is the first part of that we'll cover. I'm going to cover different dimensions of it. But the first part is really the laws of physics, okay? Because what we have found is that we live in a rational universe that follows laws that we can discover. Okay, and here I have a couple of quotes. I like to use quotes to help to show how some of the best thinkers that we've ever had as human beings, how they saw these issues and what did they say about them. I found them to be very powerful in sort of guiding our thinking. And here's a couple of quotes from a couple of the most amazing minds that we've had in the last 100 years or so, Albert Einstein and Stephen Hawking. Can everyone go on mute, please? Jotham, I think you should put people on mute if you don't mind. Thank you. So what did these two say? These are both physicists, considered two of the best physicists in the world in over the last 100 years. And what did they say about this overall, the universe that we live in? Einstein says, whoever has undergone the intense experience of successful advances made in this domain in science is moved by profound reverence for the rationality made manifest in existence, the grandeur of reason incarnate in existence. Okay, reason incarnate. That means reason meaning, you know, rational, logical thinking that is materialized in the world that we see around us. Okay, it's a beautiful expression. It's like the mind has become solidified into a physical thing. That's how amazing this universe is in the way that its laws are rational. And Stephen says something similar. He says, the overwhelming impression is one of order. It's order, nizam in Arabic. The more we discover about the universe, the more we find that it is governed by rational laws, okay? Laws that we can understand, that make sense. That's what they're pointing out. It's a rational universe, okay? This is a key thing that we've seen for over, oh, you can say 200-300 years. And every time we make further advances, the more we see that it is rational to us. Now, the most recent physics in quantum theory, which we'll talk about probably in the next session, is a bit more tricky to understand. But at the end of the day, we're still able to derive mathematical equations that explain exactly how nature behaves. So even in that case, we'll see that there is a rationality behind it, even when sometimes it's difficult for us to understand what's going on. Okay, so this is a key characteristic of the universe, right? That it follows laws, and those laws are rational. All right. The other interesting thing is that those laws that the universe is following are mathematical. They can actually be written in the language of mathematics. This is Galileo telling us that mathematics is the language with which God has written the universe. This is truly amazing to see that there is a way that we can very precisely, using logical, rational thought, right? Thought with our minds and doing math, which, you know, a lot of us in school never like to do, but the universe seems to follow it and follow it very precisely. And the more that was with Galileo back in the 1600s. Later, we have more and more confirmation of this. The further progress we make, the more mathematical it becomes. This is Paul Dirac. Dirac is one of the founders of quantum mechanics. And look at his quotes. He says, if there is a God, he is a great mathematician. He says that God is a mathematician of a very high order, and he used advanced mathematics in constructing the universe. This is not just somebody who said this. This is Dirac. He was a Nobel Prize winner and one of the founders of the most successful theory that we have ever come up with in physics. Okay, we'll learn more about it. But just see the way that they're describing how that they found that they work out mathematical equations and they find that the universe is obeying these mathematical laws. It is something very surprising, but also very beautiful. There's another quote from Clifford Pickover. I do not know if God is a mathematician, but mathematics is the loom upon which God weaves the fabric of the universe. The fact that reality can be described or approximated by simple mathematical expressions suggests to me that nature has mathematics at its core. Yeah, mathematics is at the core of the universe. I was listening to an atheistic, materialistic scientist the other day called Peter Atkins. He's a very famous, very well-regarded chemist. And he was saying, even he believes, the infrastructure of the universe, what is it built on? He said the infrastructure of the universe is mathematics. Okay. Maybe one more quote here. This is from Eugene Wigner, again, another great thinker from who developed parts of quantum theory. He actually wrote a whole essay about this called The Unreasonable Effectiveness of Mathematics. Okay, he's saying that the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Okay, why would it be? Now, this is what we are going to discuss. Why would it be that this universe would follow laws that mathematics, that a human mind can develop and understand? Why would the universe be fit? Why would it turn out that mathematics works and works so well? Right? This is a deep question that we need to discuss. Now, I want to I'm not going to go into equations. Don't run away. I'm not going to get technical into mathematics, but I just want to give you a taste of what I'm talking about in terms of how advanced, how sophisticated these laws are and the mathematics that they use. These two equations that you see on the screen here, these two are the most successful theories that we have. In fact, we can basically explain everything in the universe from these two theories. The one on the left is quantum mechanics. The one on the right is general relativity. I'll talk more about these, but just take a step back and think about this. Two equations that a human mind can develop using mathematics can perfectly explain everything that's going on in this universe, no matter where we look, billions of light years away or right in front of us, everything can be understood by these. And not just understood roughly, the accuracy and the precision that we can understand this universe is unbelievable. And I want to give you some examples of how abstract the thinking is and how well it works. Okay. Again, I don't want to scare you with technical information. There's nothing really technical you need to know here. Just the big message is that the universe is following beautifully sophisticated mathematical laws, but not simple laws. They are very complicated in the sense that it takes very advanced minds. Only the best minds in the world are able to even discover these laws. Okay, this is an example. This is something called a 6-dimensional Calabi-Yau space used in the most recent theories that we're developing called string theory, okay? This is saying that space is actually not 4 dimensions like we know, 3 dimensions of space and time. Saying actually maybe we can't see the fact that there are 6 dimensions all curled up together in a mathematical shape. This is not just a squiggle on the screen. This is, look at the equations. These are mathematically defined shapes. And we're saying that they're finding that these shapes can help us to understand even better how the universe is behaving. Okay, just want to give you a taste of how sophisticated this is, how abstract. You have to imagine a space which is multi-dimensional, but not just wishy-washy. No, precisely mathematically defined. And then we can start doing maths on it to make predictions, okay? And let me give you a taste of how accurate all of this is. It's just unbelievable how accurate we're able to predict things now. So I'll give you 2 examples, okay? The first one comes from this quantum mechanics, which I mentioned. It's one of those 2 key theories, okay? Quantum mechanics has now made predictions, and they have been confirmed by experiments up to 14 decimal places. Okay, so here's one example. We measure something, a property of an electron called the anomalous magnetic moment. You don't need to know what that is, but it's just a particular property, okay? And so with the theory, mathematically, we understand it using the equation that we had, and using it, we start to predict that if we go and measure this thing, this magnetic moment of an electron, before this theory, we thought the value was going to be 1.00, just equal to 1. You see here? Equal to 1. This is what we thought it would be. But the quantum mechanics is actually predicting the value is not 1.00. It's actually exactly going to be this number. Okay, 1.001159652180732. Yani, look at this, how accurate we are being. You know how day-to-day life we might say it's not 1, it's 1.2, right? Right? You're measuring something like a distance 1.2 meters, or 1.25 meters, right? 2 decimal places. We are predicting and confirming using these theories 14 decimal places. This is not a coincidence. This means we really have understood that this universe is very precise in the way that it behaves, and we can understand that mathematically, and we're able to predict what will happen. In general relativity, we've done the same thing here. Now, in relativity, what we've learned is that time itself is not a fixed thing, that just like a big clock in the universe that ticks, click, click, click. Time depends on how fast you're moving. The faster you move, the slower time becomes. So we've done tests on this using general relativity by moving some very accurate clocks, atomic clocks, and we've been able to test exactly how this is true, that actually the clock ticks more slowly when the clock moves faster. And look at the accuracy of how much we're able to be precise about this. We test 2 clocks, one moves fast, one moves slow. And the difference is that one clock ticks this many times, right? 10 to the power 16, one with 16 zeros, and the other one clicks 99999, and one click less, one tick less. So I'm just giving you an idea of how precise this universe behaves, and how accurate we're able to understand it using these laws and using the mathematics that they are written in to do it. this is very strange. Why would the universe be this way? Okay, what is it telling us? What can we conclude from this? That's what we're going to discuss. Okay. All right. The last couple of things I want to touch on is this. Yeah. So this is a quote from James Jeans. He's a very great physicist, and he says the universe begins to look more like a great thought than a great machine. Okay. So what he's saying is that the universe is made of things that are moving around and bumping into each other like a machine. It's working like a machine. But actually what we see is, no, it's actually like a great thought, because these laws are like thoughts. And this universe, this machine is working according to a thought, this mathematical thought. And then the physical is not as important. The important thing is that the source is a thought. These laws are like thoughts, which is a very interesting idea. All right, now bringing all of this together, I have just two things I want to conclude with in this section. Okay, one is probably the most important quote that I have ever read personally. This made a huge difference for me. It was like a breakthrough to understand how significant this is. And it's from Einstein. He says, the most incomprehensible thing about the world is that it is comprehensible. Okay? Comprehensible means that we can understand it. It makes sense. Yeah? We can comprehend. So that's what it means. It means it's comprehensible. You know, how the word is actually comprehensible. It means that we can understand it. So the most incomprehensible thing, the thing that's surprising, that doesn't make sense, is that the world is comprehensible. Why is it that we can understand this universe and how it works? Because we'll come to the opposite view where, you know, people who don't believe in God and don't believe in any kind of designer or intelligence that designed it will say, no, it's just matter. It's just blind, you know, dead matter behaving in a certain way. And that's what we see in this universe. And the question becomes, yeah, but why would it be comprehensible? Why would it not just be completely random in a way that we can't even understand it, you see? So it's very interesting, this insight that physics is giving us, that this universe makes sense to a mind that is able to understand advanced, abstract thoughts. Okay, this is one thing. And you know, the fact that we can actually study things millions and billions of light years of miles away from us, and we can really understand what's going on, is shocking. Okay, this picture here is one of my favorites from NASA. On the left here is a picture they took of this nebula called the Eagle Nebula back in 1995. It became a very famous picture. It was called the Pillars of Creation. Okay, these are like three pillars. Okay, and in it are these stars that are being born in these clouds of gas. So these are basically just clouds of gas and dust, but in them, stars are being created. So they're called the Pillars of Creation. And then about 10 years later, they took another picture of it with more high definition, you know, stronger telescope. And they analyze it, and you can see how it's changed over the last 10 years. And we can understand it perfectly using these laws, even though, look how far these things are, 6,500 light years away. This, from here to here, this pillar, just this pillar, is 4 light years long, okay? 37 billion kilometers long, okay? And it sits 6,500 light years away, okay? But in it are stars like our sun. We're able to analyze the light coming from it. We're able to understand it using our mathematical theories, these laws, and it all makes perfect sense to us. This is amazing. It's not just in our neighborhood that this works. This works through the entire universe, and for all time it works. So these are very key insights that we're learning about how nature behaves. All right. All right. I've spoken a lot. I'm just going to finish with one final thought here. Okay. And that is a quote from Stephen Hawking, because this will bring another dimension into the discussion that we will have. Okay. And it is this: what is it that actually makes these laws work? Okay. He says, even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? Okay. What is it that breathes fire into the equations and makes a universe for them to describe? So you see the idea here. Those equations that I showed you guys, okay, these two equations, we've worked them out. We wrote them on a piece of paper, okay? Why is this universe following these equations? What is it that's making the equations work? I could write other equations, right? I could just make up equations. I can imagine a different set of equations, but they won't become real. Something has to make these equations work. And that's what Stephen is pointing to. That's a really crucial thing. So we know that the equations themselves are mathematical, but mathematics is just thoughts. Something has to bring them to life, right? Otherwise, they would just stay as ideas. So this is another key insight that's coming from physics. They can't tell us what is doing it from within physics. This is a question for philosophy. Okay. All right. Now, all of this will come. We'll develop all of this into other, questions and try to come up with ideas about what is this telling us? What can we conclude from all of this? But for now, these are the key questions. Okay. Why are there any laws at all? Why is it just not a bunch of random things happening that we can't even understand? What is the origin of these laws? Where do they come from? Why are they comprehensible to a rational mind? Why are they mathematical and precise? What is it that breathes fire into them and actualizes them, makes them real? And there'll be different viewpoints for this. My own viewpoint is viewpoint number one, okay? And that is this. I believe it is very convincing and very reasonable to say the order that is inherent in these laws of physics, their comprehensibility, the rationality of those laws, suggests, it's suggestive that there is an intelligent mind that has designed them, first of all, and then has breathed fire into them to actualize a universe that obeys them. It doesn't make sense to me that they will just be there for no reason, or not even for no reason. They just happen to be there, and they just happen to be of this type of law, this kind of nature of the laws. So that's what I call the intelligent mind. I don't know what it is yet. I haven't defined it, but I'm just saying that it suggests to me that if it requires an intelligent mind simply to even discover these laws and understand them, I don't think it's unreasonable to say that the source of those laws must also be intelligent, and far more intelligent than us. In fact, Einstein referred to it as the superior mind, the superior reasoning force, the illimitable superior spirit. That's what he called it. The last thing is to say, what are the opposing views? What other views are there? there's a view which a lot of physicists, surprising to me, but they say, look, we don't know where these laws came from. They've just always been there. They just happen to be like this. And we just accept it. Okay, that's what they say. Another way of interpreting, they say, well, look, maybe there are other universes, not, within our universe. No, totally separate universes. And there are infinite universes. And they have different laws. And okay, we happen to be in one universe that happens to be ordered like this. Okay. And they call that the multiverse. Okay, it's a multiverse, means that it's more than one universes. Okay, lots and lots of universes, and they have different laws, and this one happens to be like it. And we would only be here if we could, exist in a universe that was like that can give rise to life, so that we could actually be able to ask these questions. Okay, so at the end of the day, we will all need to make a choice of what makes more sense to us. And honestly, I can tell you, the very smart guys out there, these physicists, brilliant minds, they find this more convincing for them, that these laws are just there and I'm just going to accept them. That's it, end of story. I don't want to go any further than that. I just accept the laws. What I'm saying is that, to me, that's unsatisfactory. It doesn't really make sense. It's not very scientific, actually, to just say that they're there without any explanation of how they've come about. It makes more sense to say that this is, as I described earlier, you need a mind to understand them. How can there not be a mind behind the design of them to begin with? So there are many other viewpoints, but I don't have time to go through those. Hopefully we can discuss more in the discussion sessions. I'm sorry I took a lot of time, but there was a lot to cover today. This, by the way, is the most important thing that I will share on the whole science part of the discussion. If you spend time with this, you will see how profound it is and how powerful it is as evidence. Thank you.